Okay, so you should have 6.2 solving quadratic equations in front of you. So, yeah. Thank you. So last class, we were covering what's called the vertex. So remember, we have a parabola. That's what the arc looks like when you graph the quadratic equation. We saw that on Desmos. Today we're going to be looking at what's called the zeros or the roots of a quadratic equation. So, in simple terms, the roots or zeros of a quadratic equation are the points on a parabola that intersect the x-axis. So some of us might not know what the axes are. That's okay. That's why I put that little table on the right side for us to see. So this vertical line here, that's a bit darker than the others and has labels, we call that our y-axis. I'll write it to axis. And then this horizontal line here, that's a bit darker than the others, we call that our x-axis. And so to show you what the zeros are, we're going to put points on this graph, and we're going to put one at here on the x-axis, the point that's labeled -1. I'll make it big for everyone to see. Then we're going to put a second one on the 1. So if you recall yesterday, our parabolas look something like this. An arc shape. And so when I'm asking you to find the zeros of a quadratic, I'm looking for these 2 points here where the parabola crosses the x-axis. So in this case, we drew our point on -1 and 1. So if you're going to write, if I asked you what are the zeros of this quadratic, without even knowing the formula, you can just tell me looking at the graph that the zeros are at x is equal to -1 and x is equal to 1. How did I know that? Because this point here is -1 and this point here is +1. So, because we had such great success last time when we used Desmos on our phone to find the vertex, I want to do the same thing today, just so you can get that visual understanding that I think will help you when we move on to the mathematical or algebraic way of finding the zeros. So, because when I go to the website, it crashes the projector, I took a screenshot, which I don't have here actually. So let me go to the website then. Give it 1 second, guys. If you want, when you're at home, you can download the Desmos app on your phone. And it's gonna be easier to use because then you won't have the browser bars covering some of the functions. And it'd be easier for you to pull out so you don't have to type the equation if we ever do this activity again in class. But for now, bless you. Bless you. So recall, you would tap on the bar here. It might look a little different on your phone, but you'll have a bar to type in the equation. So here I typed in x squared minus 5x plus 6, which you can see on your example on the first sheet here. That's the first example. It'll put the graph on the right. All you need to do is tap on the line. You can zoom in on your phone too. And when you tap on that red line, you'll notice there's 3 points that come up. There's 3 gray points. But today, last class, we were looking at the vertex, that peak or minimum, the maximum or minimum of the parabola. Today, what I want you to look at are these 2 points here, the zeros of the graph. And so here we have 2 and 0, like the points are 2, 0 and 3, 0. The first one on the left is the x value. The one on the right is the y value when we're talking about coordinates. So our zeros here are when x is equal to 2 and x is equal to 3. So then on your paper here, in this bottom box where it asks you what are the zeros of the equation, you're gonna write x is equal to 2 and x is equal to 3, just like in our example. What I also want you to do is here it says sketch the parabola. I want you to make sure you draw the 2 points, the 2 zeros, and then you draw your parabola facing up or facing down depending on the equation, and make sure the lines cross through those points. So when you flip to the back of the paper, you'll see 3 examples. If you don't have a phone, that's okay. Try and find a partner who does, and you can share the screen. I'll give you about 7 minutes to do these 3 examples, and then we'll take it up together. Yeah, you're right.
Isn't it negative?
Yeah, because we're looking at the x-axis.
You're thinking if I gave you the equation, like in vertex form, you're flipping that x value, right? But you can see when I gave you the vertex in the equation, you were getting the point to flip so you could graph it properly. So these ones you just write when you click on the decimals and it says 2, 0, it's x is equal to 2.
This is two. Actually, no, it's x squared plus 6 minus 2 plus 4 plus x minus 2.
You guys got it?
Yep.
Nice. Okay, so let's get eyes back up to the front and let's take up these first three. So, first, can anyone tell me what the zeros were for A?
Negative 1.
X equals 2 and x equals 3. Oh wait, no, not that one.
Yeah, A, yeah.
That one is x minus 1 and x positive 3. X plus 3.
Exactly. And so when we plot it on our chart, we can go to the 3 here, the -1 here, and did it open up or down? Up.
It would open up.
Up, right? And even without using Desmos, we learned how to know that because our A value, is it positive or negative? Positive, right? And when it's positive,
Goes up.
it opens up. Okay, so for B, what were the zeros for B? Two and -1. Yep, that's what you got too, right? And so when we put it on the graph, x minus 1, x and 2, and notice our A value here is negative, so we know it's opening down, exactly. And then the last one, what were the, not everyone got to this one, what were the zeros for C? Yep, x is equal to -2, and x is equal to, you said negative or positive? Positive 1, exactly. So we can put those on the graph. And is it opening up or down? Notice the a value. Oh, right. Good job. You're too fast. So it would look something like that. So then let's go to the next page. So now you've done it visually with graphing. Now we want to know how to find the zeros algebraically. So I'm going to give you an equation in this form. Can anyone remind me what this form is called? Factor form, because we have the two factors here. Good job. So let's think. On our graph, we had the points at -2 and 1. What were the y values you saw? What was the right value in the coordinates at all times? What number was it? You would see -2 comma what? 0, right? And remember, that was our y value. So when we're looking for zeros, we're looking for when y is 0. So algebraically, when I'm looking for the zeros, I'm gonna set y is equal to 0. And remember, what operation is happening between these two factors? I see I have my brackets here. What operation is happening between the brackets again? Multiplication, right? And so when I multiply a number by 0, what do I get? 0, right? So to simplify this even further, I'm actually just looking for when either of these are equal to 0. Because if one of them 0 multiplied by the other one, it doesn't matter what it is, it's still going to be 0. So I like to number them, and I like to look at them separately. I'll write words up here. When are the factors equal to 0? So let's look at the first factor. X minus 2, and remember, we want to know when it's 0. So in situations like these, we're looking for the variable. We know what -2 is, we know what 0 is, but we don't know what x is to make this equation true. That's the question mark. And so to do that, we need to isolate it, keep it by itself on the left side. So we need to get rid of the 2 exactly. And to do that, I add 2 to both sides, which would leave us with just the x and a 2. So now I know my first 0 is that x is equal to 2, just like you found up here. Then we look at the second one. X plus 3 is equal to 0. And again, we want to isolate the x, the variable, the unknown that we have to discover. So to get it by itself, I need to balance the equation and subtract 3 from both sides. When I subtract 3 from the right side, I'm left with -3. And you'll see this is my second 0. X is equal to -3. Just to double check, can you raise your hand if you're confused about what I did algebraically on that side, what I just highlighted blue here? Okay, that's great. Perfect. So Let's practice doing that up to D. So I'll leave the example on the screen and try doing the first 4 example problems on your own. And we'll take it up in about 5 minutes. Yeah, sure. So I'll do hash factors and then Okay, can I get? You want me to check? You put your phone away and I'll just take it out of this. Okay, so let's get your eyes up front again and we'll check our answers. So we have our two factors here and we want to find out when they're equal to 0. So for the first one we can do x plus 5 is equal to 0. In order to isolate the x, I just need to subtract 5 from both sides, which leaves me with -5, exactly. Can I get all our phones away? Can you put it in your pocket if I saw it out? Okay. And so for the second one, the second 0, we have x plus 2 is equal to 0. And just like the first one, we want to make the x, we want to isolate the x, so we got to subtract 2 from both sides, which is going to leave us with -2. So then for b, a little bit different. We have x minus 3 this time is equal to 0. So instead of subtracting 3 from both sides, we're going to add 3 to both sides, leaving us with a +3 for our first 0. Then for the second one, we have x plus 4 is equal to 0, which we subtract 4 from both sides, leaving us with -4. I'll trust if you didn't do C and D on your own, that's fine, you can try it now. But I'll just give you quickly the zeros where x is equal to 1 and x is equal to 7. And if you didn't try it yourself and double check later for homework. Then for D, the first 0 was -3, and then the second one was 9. So now I want to take up E with you guys, because I think some of us might be confused what to do when we have a number beside the x. So taking the first factor, 2x plus 4 is equal to 0. Again, the first thing we want to do is we want to isolate the x. So this time we have two numbers though. The first thing I want to get rid of is this +4. So I'm going to subtract 4 from both sides, which leaves me with 2x is equal to -4. Now, in order to isolate the x, I'm going to need to divide 2 from both sides. So I'm going to do 2x divided by 2 and -4 divided by 2, which will leave me with x is equal to, if you punch that in your calculator, you'll get -2. So unlike A, B, C, and D, where we only had to do one operation to isolate the x, here we had to do 2. Yeah.
Okay, guys, let's just scroll up for a second. So whenever you write, whenever you're solving for zeros, add the word or. Okay, so for example, C, in between x equals 1, insert the word or. Because they can't be true at the same time. Okay, x is either 1 or it's equal to 7. So between every single x value when you're solving, write the word or, please. Okay? It's like a little notation, but it makes a difference.
Okay, then we can look for the second 0. We have our x minus 5 is equal to 0. This one's just one operation. We've done it the first 4 times. All we need to do is add 5 to both sides, which will give us +5. So our zeros are x minus 2 or x is equal to 5. So now let's try f and g with your partner beside you or on your own if you want. And we'll take that up in about 3-4 minutes. I'm really happy, everyone. I just walked around and pretty much everyone got the first two F and G perfect. So if you just want to double check, our first 0 was -8 exactly, or we had x is equal to 3. And if you want to do it in your head sometimes, like after enough practice, you'll notice, oh, that's going to be +6 divided by 2, which is 3. So here, I know I'm going to have +6 divided by 3, which is going to give me my first 0 of 2. And here, I know that's going to be -8 divided by 2, which is equal to -4. Did you get negative? Yeah, good job. So now here, this is a trickier one, right? We have x times x plus 9. Don't worry, it's the same process. We just have our two factors here. But the first one's so easy because all you have to do is set x is equal to 0 and you're done. Your first 0 is 0. See, because x is equal to 0, x is already isolated. Boom, that's the first 0. I know it was like a little tricky to look at, but you'll be happy if you see that one on a test. And then the second one is x is equal to -9. Just want to make sure you saw example H, right? Yeah. Mohammed, you saw example H, right? See how I set x is equal to 0? I didn't even need to do an operation after that. Alright, sounds good. So now we're gonna get to a little bit more complicated. We're gonna have to be factoring again. So this is why it's important that if you kind of struggle with factoring on your test, maybe spend some time to practice it because it's pretty much, you're gonna use it throughout grade 10, grade 11, grade 12. So let's say this is what most of your problems are gonna be like. You're gonna get an equation in standard form. So let's say y is equal to hold on, that's your, you good? You good? So yeah, we'll do the first example. y is equal to x squared plus 3x minus 10. And so if you still have your cheat sheet that we did last Wednesday, you can always pull it out with the table to know what signs your factors are until you feel like you have it memorized or you feel pretty confident with it. But for now, we know the product is minus 10, the sum is 3, product is negative, sum is positive, so I know it's gonna look like this. The first factors are 1 and 10, which gives me 9, then 2 and 5, which when I put in my calculator gives me 3. That's the one I want. So now I can just write the factors I found, 2 and positive 5, minus 2 and positive 5. And now, just like last time, you would know what to do with that step. We just need to find the factors, which once you get good enough, you'll know in your head, oh, that's gonna be plus 2 after enough practice. If you still wanna solve it algebraically, that's fine. You can set x minus 2 is equal to 0, add 2 to both sides, it's positive 2. So our first 0 is positive 2, or it's gonna be x is equal to negative 5. So, because we want to review the factoring, let's do the first 4 on your own or with a partner up to D, then we'll take it up in a bit. Yeah.
Mom. Rip up your Holocaust and toss it. Rip it up and toss it. We'll save it for later. They'll sell it on the black market now. Are you guys doing anything fun to eat? Is anyone cooking yummy food? Who's helping to cook tonight? What, you guys don't want to cook? She's gonna be here tomorrow.
After you do this, you get this right. Well, what if this is not
Like six minus -3. 6 plus 6 minus 3 is 3. -3 plus 6 is 3. Whereas -6 minus 3 is equal. Oh, -6 is supposed to be -3. Because this is -3. This is. Oh yes, because the other possibility.
Okay, let's check our answers, everyone. If you have your phone out, can you please put it away and in your pocket? Okay, so for our first one, what was the factored form of this equation? Who wants to share their answer? Yeah? Yep. Exactly. And so, what was our first zero then? Yep. Yep, or x is equal to -35. So, our second one, who wants to give that one a try? Yeah. Did you say x plus 2 and x minus 8? So that's very close. We'll notice though that our b is a negative value. So that both, because the sum or the product is positive and the sum is negative, both of our factors are gonna be negative. So you're right, it's 2 and 8. Just the sign is gonna be -2 and -8. Okay, and so when we isolate for 0, the first one's going to be x is equal to 2 or x is equal to 8. So I'll write the answers for the C and D. If you didn't get a chance to work on them, you can double check your answers at home. Now, notice for these first 4 examples, because I just want to test that we can find the zeros of the quadratic. I gave you standard form equations where the A is equal to 1. So you didn't have to decompose, because I know we're still kind of iffy on that process, like not 100% solid with it. So the next 2, notice our A value is not equal to 1. The first one's 4 and the next one's 6. Because we're running low on time, I'm gonna leave those 2 for homework. And if you want to double check your answer, you're still iffy on decomposition, please, ask a friend. If you want, you can email me or Miss Tam for some help on that. For now though, let's go to the backside, the page 3. Front side of page 3. So this is going to be related to application. So why is it important to find the zeros of a quadratic? How does it apply to our daily life? Well, parabolas model many real life scenarios. So like I said with the test, a lot of us were really solid on the knowledge and understanding part. It was when we got to application and communication where we weren't able to 100% explain our understanding of how factoring could apply in real life situations. So for here, just to give you 2 examples that we've worked with in class, the first situation that can be modeled by a parabola is the arc of a projectile. So in this case, a projectile can be like a basketball. When we shoot it into the net, its shape is going to look like an arc. If we wanted to find the maximum height, we would use the vertex, and in this case the zeros would tell us how far it traveled. Projectile can also include things like plane soars through the sky. We can see how far it traveled, how high it got through the air. One example we worked with last Friday, which is a bit more hard to visualize, is we can use this in business to model revenue and costs, just as some examples where we try to maximize our revenue and minimize our costs using the vertex. We'll work with those problems more in the future, but for now, we're going to focus on finding the zeros. So, an example application problem here. We have a paper airplane and we throw it in the air. We model its path with the equation y is equal to minus x squared plus 2x plus 3. So right off the bat, what is this arc going to look like? What is this parabola going to look like? Is it going to open up or down? Down? Down, exactly. And how do we know that? The A value is negative, exactly. So this airplane, when it's thrown, it's going to look like that. And so now we continue the question. X represents the horizontal distance traveled in meters. And we want to know how far the airplane traveled when it lands on the ground. So notice, if I asked you how high the airplane got, that would be me asking you to find the vertex. But I'm asking you for the distance it traveled. So we want to find the zero, the endpoint over there, when it hits the ground. In this case, you're going to imagine the x-axis as the ground. So that's how you can visualize it. And then to find it mathematically, it's going to be exactly what we did on the last page. We have the quadratic equation. We have the model of the flight of the paper airplane in standard form. And in order to find the zeros easily, we're going to want to convert this to factored form. So I'll write here, we're going to factor first. So RA here is not equal to +1. It's equal to -1. So I want to factor out that -1 first. When I take out -1, I'm left with x squared minus 2x minus 3 within the brackets. Now, within the brackets, our quadratic in standard form, the a is equal to 1, so you do not need to factor with decomposition. We can just do it the same way that we did for a, b, c, and d. So you can use the table, but if you have enough practice, you might be able to start to recognize what the factors could be just by looking at it. So 3 is a pretty small number. There's only one combination of factors that can multiply to that. It's 1 and 3 would multiply to 3. And because it's a -3, I know that the signs of the factors are gonna be flipped. And so we have a 2 here, that's negative, our sum is negative, so the bigger factor is gonna be negative. So the 3 is gonna be negative. So I have x minus 3 and x plus 1. If you wanna use the table still, that's 100% okay. If you feel like you're more comfortable with factoring, you can try doing it in your head just to challenge yourself a bit. Here we have the -3 times +1 is equal to -3. -3 plus 1 is equal to -2. So now that we have it in factored form, just like we did at the very beginning, we're going to take the first factor, x minus 3, and we're going to set it equal to 0. So in this case, our first 0 is x is equal to 3, and now I just want to double check the second one. So the second one is x plus 1 is equal to 0, which is equal to x minus 1. So our zeros could be 3 or -1. Now, remember, this is an application problem, so we're trying to apply this to a real life scenario. X is measured in meters. Can I throw something -1 meters in distance? No. So we can rule out this 0 here, and we can use the first 0 we found, x is 3. And remember, some people on the test, when you did your application problem, you didn't give a final sentence. You got it right mathematically, but we always need to write a sentence to demonstrate that you understand what the question is asking. So here we can write the paper airplane traveled 3 meters before it lands on the ground. And if you're ever unsure about how to write the sentence, a trick you can use is just to look at the question and restate it as a sentence. So here it asked, how far has the paper airplane traveled when it lands on the ground? I just restated it. The paper airplane traveled 3 meters when it landed on the ground. So now I'm gonna leave this example here on the screen. You can work with your partner if you want, or you can try it on your own. Let's do that last problem on the sheet, and we'll take it up in 5 minutes. being upside down.
Is it maybe X plus? X plus 2, X plus 3? 3? No. It's just that 6 plus 2. No, what are you doing? Do you have a first one? Oh, it's only 272 and 19 something like that.
Yeah, that's the one. Okay, those
Good morning, Margaret, no staff and students. If you're able, please stand for the land acknowledgement and the national anthem. If you're in the hallways, please stand still. We acknowledge we're hosted on the lands of the Mississauga of the Anishinaabe, the Haudenosaunee, Confederacy, and the Wendat. We also recognize the enduring presence of all First Nations, Métis, and Inuit peoples.